Welcome back. Greetings. This is session 6. We were talking about data preparation in the previous sessions, in the previous parts. We are now moving into data cleaning part. Let me share my screen. So in this part, let's have some examples, some better understanding of what we mean by data cleaning. Here is a data set. This could look like an Excel file, potentially generated from an online entries by humans. You have name, assumption is this is first name. You have the city, Toronto, Boston, Los Angeles, London, Las Vegas. You have income. The assumption is these are all in USD. And then the age is given as 1 or 2 digit numbers. Now, as you can see from this simple Excel file, you can see that I have some empty cells, this cell and this one, and this is going to be a significant issue when you want to run your code. The code is going to actually be confused because remember, we are talking about computers and not humans who are intelligent and could potentially guess what this number is going to be. That's not the case. The computer is supposed to actually understand this empty cell. With your help, you are the one who is going to identify how to fill in this empty cell. Now, one of the easiest thing to do is simply to ignore the entire row. You have tens of thousands of rows and only 200 of them happen to be problematic. You could potentially go and delete them from 20,000, 100,000 lines and rows of that Excel file. Removing 200 should not have a significant impact in your analysis, in your conclusion. What happens if you have 1,000 rows and you have 10% of that exhibiting a missing cell? So 10% means 100 rows. 100 rows in 1,000 rows, that's going to be significant. Now, so you can't just easily go around and delete the entire row. One of the things you can do, you can potentially fill in manually. You can say, okay, I'm just going to have some guess. I'm going to put $60,000 here. I'm going to put and assume that this is 27. It's kind of a you fill this in manually, and you expect that these numbers that are coming at you because you are a human, you are processing this behind the scene by looking at the data, it doesn't have an impact. First and foremost, when we are talking about 20,000 rows, you can't just go in and manually fill in. Second, how do you know that you are going to guess the right number for Los Angeles versus the London or Las Vegas versus the New York versus Toronto? You could potentially say, I'm going to use a global constant. A global constant means you go and take a look at the United Nations database, and the database says the average income for the young generation, say 25 years old until 45 years old, is going to be $60,000, and you're going to put that in. But here is the problem. You ignore the fact that this is Los Angeles. You ignore the fact that this is New York. And the income scale is actually quite different than Boston, than London, than Las Vegas, than any other cities in US or in Europe or in Canada or in elsewhere. You may be able to use global constant, and it depends on the nature of the data. Who decides that? You, as the data scientist, as the expert of the domain, the knowledgeable in the domain, you can decide. You could potentially say, I'm going to take the mean or median. Please refer to the remedial recordings that we had, where we discussed what the mean means, average, what the median means. You could potentially say, okay, I have some numbers. I'm going to actually take the average and put the average here. I'm going to take the average and put them here. But again, in Los Angeles, a salary of $200,000 may look like a $80,000 in a different city in US. Because in Los Angeles, you are going to pay a huge rent. If you have bought a house, your house is actually on a different scale than if you bought the house in a rural area, in a different area. So you are going to be basically deceiving the process. And it's not actually appreciated if you ignore the fact that this is Los Angeles or this is London, and you basically do what pleases you. You could potentially say what is the most probable value. And the way you're going to do it, you're going to go into Los Angeles municipality and potentially the state of California. You're going to take a look at the government data set. And from there on, you're going to be able to actually say, this is the most probable value for Los Angeles. Or you take a look at the London data set and you're going to say, based on the job demographic and the job age groups, I'm going to say that this is going to be the case. That is, so you are the expert in the domain, and you need to pick up your approach. There are different approaches. One approach is just to remove it. But again, if it is 10% of the data, this is going to have a significant impact. You never know. Maybe that kind of a data is going to have a special meaning that you're supposed to extract at the end of the data science project cycle. You could potentially have a noisy data. We talked about noise coming from different areas. It could be the electronic device that is actually making noises. It could be disconnectivities. It could be just a noise coupled with the data that is provided to you by the customer and the client. What you could do, you could smooth it. And I'm going to explain binning as a mechanism where you are going to smooth it. We are going to have buckets, we are going to have bins, and we are going to put the numbers in the buckets and bins, and hopefully eliminate some of the noise. The expectation is that the noise is going to be high frequency, and hopefully by smoothing, you're going to prevent the high frequency data. But that's not going to be the solution all the time, because if you're doing day trading, for example, you really need high frequency pieces of data. You need high frequency points on the stock markets so that you can actually make a decision correctly on a minute basis, on a second basis. And today, high frequency trading, they actually do the trading in a less than a second. They make a decision in less than a second. Regression, you could potentially try to consider the collection of data that is available to you. And then you say, I would potentially consider a line, whether a linear line or a curve, to fit the data to the best of my ability. Curve fitting. And in that curve fitting, you could potentially say, listen, if there's any missing data in between, I could do interpolation. If there's any data missing outside of the range of the data available to me, I could do extrapolation, because I now have a function, and for example, for that line, that I could potentially utilize to fill in the gap, any missing information. Outlier, we talked about it. You could potentially do clustering. You could have a set of rules, and based on the set of rules, you can potentially say, this is my cluster. This is the way it's supposed to be. Maybe it's just the distance that is important to you. You take a look at the variables, you take a look at the parameters, you're going to say that these are the things that are important to me, and whoever has that kind of attributes, I'm going to call them insider. So for example, you take a look at the village, and all the people in the village are actually farmers. It's not about distance, it's about the job. And everybody seems to be living their life as a farmer. And now suddenly someone moves into that village, and in that village it starts doing stock trading. That would be quite surprising. That could be quite strange, that you moved from a dense area where you are supposed to be in constant contact with different companies, CEOs, and to be upfront and available to grab the data. And then you move to a village where everybody is a farmer. The good thing about today's technology is that you can do that because of the internet. but it's strange. Neighbors are going to ask, why did you move to that area? So clustering can happen because of the attributes, the rules, the set of rules that you have actually accepted. We are going to go and talk about the binning first, and then regression, and then we talk about the clustering. Now, this is a binning. Take a look at my sequence of numbers: 4, 8, 15, 21, 21, 24, 25, 28, 34. I have 9 numbers. And one of the easiest way of binning is just to divide them in equal frequency. So I'm going to say I had 9 numbers divided by 3 because I have 3 bins, and I'm going to have 3 numbers in each bin. So 4, 8, 15, that's 3. 21, 21, 24, that's the follow-up sequence. 25, 28, 34, that's the last sequence that I want to put. So I did binning by equal frequency. Now, in order for me to smooth the data, and if you want to argue, in my case, you could say 4 and 8 seems to be very close, and 15 seems to be far away. That's kind of a strange spectrum that I have. Now, you could say I'm going to put them all and replace them all by the average. Take a look at 4 plus 8, 12, 12 and 15, 27. You have 3 numbers, 27 divided by 3, that's going to be 9. Similarly, 21, 21, that would be 42, and plus 24, that would be 66, divided by 3, that would be 22. And then you get the next one, average, you put them in. You replace all 3 numbers without an exception with the average value. This is going to smooth it, of course. Averaging is well known to be a low frequency filter. It's going to be low frequency, and anything that is going to be outside of the range, rather considered high frequency, are going to be removed. And you don't see changes here. 9, 9, 9. You see 22, 22, 22. It looks like a level line, level line. Another thing you could do, potentially, you can basically do the binning using the boundaries. Now, I know that the average is 9. Anything below the average is going to go to the left boundary. Anything above the average is going to go to the right boundary. So 4 is, of course, the left boundary is going to be there. 8 is less than the 9, so it's going to be 4. So I'm going to replace it by 4. 15 is the right boundary. I'm going to leave it. 21 and 24 are going to be my boundaries. I'm going to put them there. And then this 21 is less than 22, and I'm going to replace it by 21, the left boundary. If this was by any chance 31, just for the sake of my argument, 25 left boundary is left, 34 right boundary is going to be untouched, but this is 31. 31 is bigger than 29, and I'm going to replace this by 34. In this case, in any example, you can see that 28 is less than 29, and we have replaced it with the left boundary. And then I would like to discuss on the regression in the next recording.